Dear students, welcome to the world of chemistry, chapter 6, Thermodynamics. This is the e-content lesson 13. Let us learn. Today we will learn about the delta G, that is gives free energy for the condition to be spontaneous, and third law of thermodynamics. Can you give the equation, the famous equation, Gibbs-Helmholtz equation? What is the relation? Delta G and delta S and delta H. By connecting, we get Gibbs-Helmholtz equation. That is, delta G is equal to delta H minus T delta S. In this equation, what is the energy factor and entropy factor? Can you give? Energy or enthalpy factor is delta H and T delta S is the entropy factor. And what will be the condition for delta G to be spontaneous? Delta G is negative for a spontaneous process. That is, for every spontaneous process, delta G gives free energy decreases. We apply the energy factor or enthalpy factor and entropy factor in this equation. If both factors favors, equation become delta G is equal to delta H is negative and T delta S become positive. Therefore, delta G is negative, that is, process is spontaneous at all temperatures. Condition 2. If the enthalpy factor favors, entropy factor oppose, what will be the value of delta G? That is, from this equation, delta G is equal to delta H minus T delta S. Here, delta H become negative and delta S become negative, that is opposes. How delta G become negative? If delta H is greater than T delta S for a spontaneous process, that is at a low temperature. Condition 3, the enthalpy factor oppose and entropy factor favors, what will be the value of delta G? That is, enthalpy factor oppose means delta H become positive. Entropy factor favors means delta S become positive. What will be the value of delta G? The delta G will be negative if T delta S become greater than delta H. That is, delta G become negative for a spontaneous process at a higher temperature. Can you give the entropy value in the case of solid, liquid and gas? What about the entropy of solid? Very less. Gas have higher entropy compared to liquid and solid. What about the entropy in the case of perfectly crystalline solid? Very minimum or taken as 0. What happens when temperature decreases then up to 0 Kelvin? Entropy of pure substance decrease with the decrease in temperature. Can you define third law of thermodynamics from this? It states that at absolute 0, the entropy of all perfectly crystalline solid may taken as 0. How will you calculate the absolute entropy of pure substance at a different temperature? Students, can you give? It is the application of third law of thermodynamics. Delta S0 is equal to sigma delta S0 F of P minus, that is product, minus sigma delta S0 of F of reactants. Students, then we can do an assignment. Write an assignment. What is residual entropy? Can you define residual entropy? Residual entropy is defined as there are certain solid which possess some entropy even at absolute zero. Students, you have all clear idea about the condition for Gibbs energy to be spontaneous and third law of thermodynamics. Learn well. Thank you.